Hello, this is Mr. McMurray again. We're talking about orbits of Kepler's first and second law lab that we have to do, and hopefully the blackbirds have infested the neighborhood. I would say infested, but they have a flock of them has landed. Hopefully they're not too squeaky and squealy and whatever. Anyhow, uh, so first of all, starting off, there is this little simulation showing all the first four planets, how they rotate um, around each other and around the sun, in relation to each other around the sun. But there is no actual question there, okay? Um, Now, once we get down here, we'll start doing this. One thing I would suggest is you go up here and put show inline question, which means it gives you the whole width. So I think it's easier to see. Some of these are kind of small and the screen's not very big. So I think it's helpful if you do it in the large screen, although I'm not always a fan of that. Also, remember you got to get outside of it to scroll. That's always a good thing. All right. This one has several different settings. This is the Earth and Sun. The Sun here, the Earth here, rotating it. You can show the force of gravity, which the blue arrow showing the force. Notice they're equal to each other. They always are. Equal in opposite directions. And if you hit play, then it will show as the Earth goes around, shows how this force is still attracted in equal and opposite as it goes around. Velocity shows how fast it's going and the angle that it wants to go, but since the force of gravity is pulling it this way, it ends up going in between that, which gives it a path, which is like so. Okay, if you hit that one, it will trace the path at least almost a fully around, and then it will redo it when it gets back. All right, and there's also a grid just to help you see how close or far it is from there. So if you, this is like the second square here, and this is about the second square there. So you can see it's, in this case, they're saying they're about equal distance all the way around. Just kind of help you estimate that. But at any rate, you can turn those on or off as you would like. Okay, I'm just going to turn it back to gravity now. There's also a gravity on, gravity off button. It's on right now. If I click on off, it goes off, and you can see what happens. If I turn it back on, then we can see what happens and see if it's too late to keep the Earth going around the sun or if it will actually come back. Okay, kind of interesting to do that. Just turn gravity on and off and see at which point you can survive it. Okay, in this case, we turned gravity off for a little bit, and we did eventually pull the Earth, went quite a bit farther away, but it did eventually pull it back in. And then, ooh, as it gets closer, look at that. Okay, anyhow, kind of interesting things there now. This one has the sun and Earth, but it also has the moon trying to go around the Earth here. So kind of shows how that works, which is makes a very pretty pattern here, almost like a spirograph. I don't know if y'all know what that is. Don't make me feel old. If you want to redo it, you can always click the back button there, so that's a good one. You can speed up the process if it's not happening fast enough for you, and it will still show the same eventually picture. Or if it's going too fast for you, you can slow it down, but it's going to give you the same results at either rate. Okay. Then we have the Earth and Moon. Okay, same thing. All right. You can turn gravity off. You turn it back on, see what happens. Okay, anyhow, that's kind of fun. And that's on slow. If you're going to turn gravity on and off, slow is probably a good option. Once you turn it back on, then you can probably speed it back up to normal speed and just see what happens. It's always kind of interesting. All right, to see what will happen. All right. Anyhow, and the last one is the Earth. And if there's a satellite going around the Earth, what will happen to it? Okay, and here it goes. Okay, so you see how those are your different options up here on the side. All right, now let's go down a little bit, and then you ask once you do that. First of all, it's going to have you play with a lot of these different things. All right, try the different check boxes to show the velocity or the path, try on and off gravity, the different scenarios, Earth and space station, Earth and moon, Earth, sun, all those different ones. Okay, now once you've done that, then you're going to identify all the statements that are true. So you're going to pick one here. All right, let's just say I picked that one. All right, then the next time you notice that's not available. So you're just going to keep doing that until you've done all 5 of the correct answers. Can't tell you off the top of my head. Is that right? I don't know. Okay, you'll have to figure that out for yourself. Okay, now section 2 is a little bit different. They're going to show what happens to a couple of different in orbit if the object is moving faster or slower. Yes, it's a planet. Okay, I was going to make sure it actually says a planet. Now to do that, say for example, the first question down here is going to say you're going to put the velocity as a very slow for the planet, such as 10,000. So you notice this one does not have a button to launch the thing. You have to put in your speed here first, say 10,000. And when you submit that, you don't get any points for it. Sorry, I don't think. No, I don't think so. But at any rate, then it will let you launch the simulation and it will show you what it wants you to see. Okay, if you don't put in the speed there, it will not. And so the first time it says to do 10,000, the next time says 30,000. So you have to go back, change it to 30,000, and then run it again. Okay, you will not have a spot on the simulation where you enter it. You will just have to enter it on question number 1. So change it to 30,000, submit the answer, and then do it again. Okay. All right, and then you have some questions about that, what happens, and so forth. And then this one, they just want you to try it, trial and error. Just keep trying different speeds to see what's the minimum velocity that will keep the planet from colliding with the star that's circling around. Okay, and then once again, you've got some things to check that are true. If they're not true, don't check them. If they are true, check them. All right, then we go to non-circular orbits. All right, a lot of planets and so forth are not a perfect circular orbit. Even satellites and comets and some other things also have that characteristics. And so basically, you're going to launch a simulation, and it already has a speed set, so it's less than the speed required for circular orbit. Okay, so if it goes slower, what happens to the orbit? Okay, and then you pick which one is closest to the simulation once you see it happen. All right, and then you will have a place where it says where's it going the fastest, where it's going the slowest. If you look at the arrows, the force of gravity, where there's the strongest force on it, that's where it's going to accelerate the most. So where the arrows of gravity are the biggest or strongest force of gravity, that's where it's going to go fast. When it's weak, that's where it's going to go slow. So that's another way to look at those questions. Okay, then it's going to do the same thing, but this time you have a speed greater than what's required for a circular orbit. Same thing, you're going to pick where it's faster or slower at. And that means and it will point that out on the drawing, but that means that 2 of the blanks will be empty because there's 4 blanks and there's only a place to drag the fastest button or the slowest button. So obviously 2 of them will still be blank. All right. Then once again, you're going to select all that are true here. And same thing here. Things are true, and then you're basically done. There was one with very long, complicated formulas for the gravitational acceleration and blah, blah, and figure out what speed and what blah, blah, blah it would be, and we're not going to do that. So yes, you can say thank you, and yes, you're welcome. All right, let's have a great day, and hope you enjoyed the lab.